We're going to take a look at graph and absolute value as well as piecewise functions. So absolute value, you know that whatever that is, it just makes it positive. Okay, and it looks like a V. So let's prove that. What is the positive of -4? Positive 4. Positive -3? Positive 3. Okay, so it just makes all your values positive. Let's go ahead and plot that. -4, 4, -3, 3, -2, 2, -1, 1, 0, 0, and so forth. And you can see that it's becoming a V. We can also look at this as an equation y equals x. And what does that look like? A straight line through 0, 0, increasing with a slope of 1, 1. But because we know it's only positive, we can't have these negatives, so it really looks like that. So you can think of it as putting in what we learned previously on transformations. What would happen to this graph without plotting the points if we were to have, instead of absolute value of x, if we were to have absolute value of x minus 4? Again, what does it mean when it's inside the parentheses? It's x and opposite. So that means we're going to take it and move it 4 values to the right. 4 values to the right. So every single point, 4 values to the right. Or you can think of it as a line, y equals x minus 4, and this is 4 values down because it's outside. So you can take the line, the parent graph like what we have, and then move it down 4, or you can take the absolute value and move it right 4. All right, so I'm just going to rough sketch it, and yes, go ahead and copy this down. We can also start with the equation of a line, which we can see it intersects at -4 and has a slope of +1, right 1. So either way, and now we know that it can't be negative, so we're going to reflect that line up. So if you look at that, that looks like you've moved every single point to the right 4. And that's what I'm doing, counting every single point to the right 4. And that looks exactly like our sketch. So whether you want to think of it in terms of absolute value, or you want to think of it as an equation of a line, without it being negative, either way works. Now we're going to take our absolute value function and make it into two pieces, one that slopes down and the other piece that slopes up. So I'm just copying the left-hand side piece, the one that slopes down, and then I'm going to copy the right-hand piece, the one that slopes up. This is called a piecewise function, anything that you can break up into more than one piece. Now, what does that mean? You can have those pieces rewritten as two separate equations. So one going down is still a straight line, so it's still y equals mx plus b. All right, let's calculate the slope. So it's going to go down 1, right 1. So that's going to be -1 over 1, which is -x. And what is across the b? Plus 0. So simplifying, y equals -x. So that's the equation of that line. What about this one on the right? Y equals mx plus b. What's the slope? It goes up 1, right 1. So positive over positive is going to be +1, so that's x. And what is it across b? Plus 0. So simplifying to y equals x. So that is the equation of that line, and the other one is the equation of the other line. But it's a piece, right? It doesn't work for all values of x, so we have to separate the values of x. And where does that separate? At 0. That's what a piecewise function is, more than one piece. So you have your output value for y, you have your equations, like we just found out, but you also have what you call your domain restrictions, your restricted values over x. So if x is less than 0, use that one. If it's x is greater or equal to 0, use the right-hand side. Now be careful because it does include the point 0, 0. When you have an open parenthesis, it means that it does not include. When you have a closed bracket, it means it includes. And because there's a point at 0, one has to be open, the other has to be closed. If there was a hole, like a circle with nothing, then they'd both be open. But you can interchange those. It doesn't have to be open and then closed. It could be closed and then open. So that's what a piecewise function is. So you can take an absolute value and make it into pieces made of two separate equations. So you can write the absolute value equation, or you can write those two lines. Now we're going to actually practice that. So let's say we have this function here. Okay, so we're graphing piecewise functions. All right, what have I done to it? I'm going to flip it over. The outside is x, opposite. And then I'm going to, inside is x and opposite. I'm going to move it to the right, 1. And then outside is y and regular. So that means I'm going to move it up 3. This is a faster way to graph. So if I take my absolute value function, which I know the parent, flip it, so it looks like this, and then move every single point right 1, up 3, right? It will end up somewhere like this. So let's do that. Starting off with the flipped version of it, I'm going to move it right 1 and up 3. For every point, I'm going to move it right 1 and up 3. So right 1, up 3. And this is going to be my final graph because I already flipped it. Right 1, up 3. Of course, you can also just plug it in and evaluate it as a table. So I'm going to actually do that so I can double check to make sure I did my transformation right. So what does that mean? Plug in -4 into the equation there. So if you plug -4 into the equation, I'm just going to quickly use a calculator. So it's -4 minus 1. Take the absolute value of that, so it's going to be +5. and then it needs to be negative 5 plus 3, which is negative 2. All right, plugging in negative 3, you're going to get negative 3 minus 1, which is negative 4. Take the absolute value, which will be positive 4. Then there's negative outside, so it's negative 4 plus 3, which will give me negative 1. Plug in all the values for x, you'll get the following output. I'm just going to double check a couple of points. That's what I'm doing right here, and you can see it lines up perfectly. All right, let's split it up. Let's tear it into pieces. So I can see it's going to tear into piece right here. So the left-hand side is one piece, the right-hand side is the other. So let's take a look at my restriction. Domain must be less than what number? 1. On this side, domain has to be greater and equal to 1 because there's no hole. It's shaded in. All right, so one has to be, strictly, and the other one equal. All right, so let's look in at the left. Let's go ahead and just copy the graph in. All right, let's copy the graph from the right-hand side. So those are my two pieces. All right, let's look at the one on the left. That's a straight line, so y equals mx plus b. The slope is up 1, right 1. That's going to be 1, so that's x. And then what is across the y-axis? Add 2, plus 2. All right, looking on the right-hand side, again, y equals mx plus b is a straight line. It's going to go down 1, right 1. That's going to be negative, so negative x. And what does it cross b? Add 4, plus b, plus 4. All right, so those are my two lines with these restrictions. So the left has the restriction on the left, the right has a restriction on the right. So how do I write that piecewise function? I write the first one, which is x plus 2. And how is that restricted? X is always less than 1. I write the second equation, which is y equals negative x plus 4. How is that restricted? X is greater or equal to positive 1. That is a piecewise function, and this is how you write it. All right, so go ahead and give this one a try. Let's practice.